In the last video, we went over the first 3 of 6 methods for solving limits. We covered all of the limit at infinity rules. This video, we're going to focus on if x is going to a number. So instead of x going to infinity, x is going to go to some constant c. And that's going to completely change how we approach the problem. Our first method for solving a limit as x goes to a number is going to be to try to plug in that number. If it works and we get an answer out, then we're done. So for example, if we have the limit as x goes to 0 of x minus 3 over x plus 1, if we plug into this, trying to plug in 0, we'd get 0 minus 3 on the top, which is negative 3. That's fine. The numerator can be anything. It could be positive, it could be negative, it could be 0, and that's fine. And then in the bottom, 0 plus 1 is 1. So we'd get negative 3 divided by 1 is negative 3. So if you can just plug in without dividing by 0, then you're done solving the limit. But if you plug in and you get dividing by 0, you're going to try to factor next. See if anything can cancel out. So factor, and this will work for 0 over 0 cases. So dividing by 0 is what indicates that you need to factor, and factoring should work if you have 0 over 0 as you plug in. So for example, if you have the limit as x goes to 5, and in the top you have x squared minus 25, and in the bottom you have 6x minus 30. Well, you have the limit as x goes to a number. So the first thing you should do is try to plug in that number. If you try to plug in 5 to this, you'd get 5 squared is 25, minus 25 is 0 in the top. The top can be 0. If this comes out to be 0 divided by 10, my answer is 0, and I am done with the problem. But when I plug into the bottom, 6 times 5 is 30, minus 30, we get 0. So this is not going to be our final answer. This is going to be our case. This is going to indicate that we have a hole in the graph. And if you think about the limit of a hole, from the left and the right-hand side, you approach the same number. We just need to figure out what that limit is by factoring. So the limit is going to exist and be finite. If we plug in and get 0 over 0, it's just going to take us factoring to figure out what the final answer is going to be. So we're still going to take the limit as x goes to 5, but we're going to factor both the top and the bottom. The top is a difference of 2 squares, so it's going to be x plus 5 times x minus 5 to be x squared minus 25. And then in the bottom, we could pull out a 6 times x minus 5. That way these x minus 5s cancel, and now we can go back to that first go-to method, try to plug in again. So if we try to plug into the top, we have 5 plus 5, so we'd get 10. And the bottom just has a 6 left in it. So our answer is 10/6. We could leave it just like that, or we could reduce it to be 5/3, or plug it into our calculator and see what it is as a decimal, 1.6 repeating. So we see the number we get. We weren't allowed to plug it into the original function, so it would be a hole in the graph. It is a discontinuity, but from the left and the right of this, the graph would be approaching 5/3 or 10/6 or 1.6 repeating. So that is our second method. Our last method is if plugging in doesn't work, and then you try to factor to get rid of what was making you divide by 0 when you plugged in, and that doesn't work. Your last ditch effort, your last method is going to be a table of approaching values. And this is what you would use for if you plug in and you get a number divided by 0. The reason why is a number divided by 0, that case would give you a vertical asymptote graphically. A vertical asymptote is something that makes you divide by 0 that factoring and canceling won't get rid of. So a vertical asymptote could look a few different ways. You could have an up arrow to the left and to the right of the number that makes you divide by 0. So if you follow these both in, the limit there would be infinity. So there's one of our possible answers for this. You could have a vertical asymptote where both arrows go down though. So you have that number where you have that dotted line. There's your asymptote. It makes you divide by 0. You can't cancel it out. But if you follow in both arrows, the limit would be negative infinity. And then our last option is that our arrows could be going to different directions. Up, down, or down, up. The limit here would be D and E. Does not exist. From the left and the right, you don't get to the same number. So if you plug in and something makes you divide by 0, so you don't get your final answer, and you realize you have a number over 0, you can still try to factor, because it should make plugging that table of approaching of values in a little bit easier. But ultimately, you're going to have to figure out which way does this vertical asymptote look. Is the answer infinity, negative infinity, or does it not exist? So, for instance, if we have the limit as x goes to 4 of x plus 4 over x squared minus 16. So first go-to method, if x is going to a number, not infinity, we're going to start by plugging in. The top is 4 plus 4, which is 8. The bottom is 4 squared, which is 16. Minus 16, we get 8 divided by 0. That doesn't give us our answer. We can't do 8 divided by 0. Your calculator would say an error. But it does give us our case. A number divided by 0 is a vertical asymptote. Now the question is the limit infinity, because both arrows go up, negative infinity, because they go down, or if they go opposite directions, our final answer is going to be does not exist. Before we jump right to making a table, I do like to factor, because there's a chance that maybe we plugged in wrong and it was supposed to be 0 over 0, and we missed the opportunity to cancel out that denominator and plug in and get our final answer like we did for a whole. If we don't try to factor, we might miss out on this opportunity where, hey, things cancel in life is a little bit easier than having to make this whole table. So I'm always going to try to factor, even though I do believe it's a vertical asymptote, because I think we plugged in correctly. I really do think we have a number divided by 0. So to factor the top, well, we can't. There's no greatest common factor between x and 4. It's not a difference of two square numbers. But the bottom is, it's x plus 4, x minus 4. So something does actually cancel. We cancel the top, so we'll just put a 1 there to hold its place. And all we have left in the bottom is an x minus 4. So now if we try to plug in, to the top we'd get 1, and to the bottom we get 0. Still indicating we have a vertical asymptote. So we definitely have to make our table. Factoring is not going to give us our final answer. But now we're going to have an easier time making the table, because I'm going to plug into this factored form to figure out what direction the infinities are going for those arrows. So where I'm approaching on the table is 4. It's the limit as x goes to 4. So I'm going to choose something near 4 to the left, so 3.9, and something near 4 to the right, so 4.1. And I could plug into the original version and see what I get, but I'm going to plug into that factored form. We did that work to factor. I'm going to use it to make plugging in a little bit easier. Because if I plug into the top, plugging in 3.9 to the top, well, the top is just 1, so top is always going to be positive. Plugging in 3.9 to the bottom, 3.9 minus 4 is going to be negative. So this is going to be an up arrow or a down arrow for this vertical asymptote. Positive divided by negative, this is a down arrow. If the other arrow is going the same way, my answer is going to be negative infinity. If the arrows are going opposite ways, it's going to be D and E. So let's plug in 4.1 to this factored form. The top is 1, so the top is positive. We don't care about the value we get, we just care about the sign of it. And then in the bottom, we have 4.1 minus 4, which is going to be a positive. So this arrow is going to be an up arrow. Here's what our vertical asymptote on the graph looks like without ever having a picture of the whole graph. So a number divided by 0 indicates we have vertical asymptote. There's a down arrow, so our limit from the left-hand side is negative infinity. From the right-hand side, it's positive infinity. Since our fingers don't meet as we trace the graph, the final answer for this is that the limit does not exist. So there's our 3 other methods for a limit as x goes to a number. Always try to plug in, because you might be able to get your final answer. If that doesn't work, factor. Factoring should always work for 0 over 0. If it doesn't, then check your factoring, because something went wrong there. Or maybe it wasn't truly a 0 over 0. Maybe you plugged in incorrectly. And then after that, use the table of approaching values. So you can plug in. If you get a number divided by 0, you can still try to factor, because that made making our table a little bit easier. I didn't have to use a calculator at all. But we had to make our table of approaching values to see which of our 3 options for a vertical asymptote, which limit we got. And this one, the limit does not exist since our arrows go opposite directions.